I'm going to explain about meaning and technique of differentiation and how to use linear approximation in value.
We're presenting about question 2, which requires us to find dy over dx for the given function using differentiation techniques. For part A, I will use product rule and chain rule, while for part B, I will use quotient rule and chain rule.
Good morning everyone. I will explain question 3, which is how to find dy dx using implicit differentiation.
So for question 1, meaning of differentiation is one of the two important concepts apart from the integration. Differentiation is a method of finding a derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. So now I'm going to explain three techniques of differentiation. First is product rule. Product rule is used to find derivative of the product of two functions. The formula is uv equal to uv prime plus vu prime. So for the quotient rule, a method used to find the derivative of a function that is the ratio of two differentiable functions. The formula is dy by dx equal to vu prime minus uv prime over v squared. And for the last is the chain rule is derivative of the composite function is the derivative of the outer function escalate at the inner function multiplied by the derivative of the inner function. And the formula is dy by dx of x of g x equal to f prime of g of x times g prime of x.
The function consists of two functions multiplied together, namely x power of 4 and ln 3x minus 1. I will apply product rule. The product rule states that the derivative of uv is equals to d over dx, uv equals to u dv over dx plus v du over dx. So we can let u equals to x power of 4 and v equals to ln 3x minus 1. Then we have to differentiate it and we get du over dx equals to 4x power of 3. Next, to differentiate v equals to ln 3x minus 1, we use the chain rule. The derivative of ln u is equal to 1 over u du over dx. Therefore, dv over dx equals to 1 over 3x minus 1 times 3. So we get 3 over 3x minus 1. Then we substitute into the product rule. So we get dy over dx equals to x power of 4 times 3 over 3x minus 1 plus ln 3x minus 1 times 4x power of 3. Hence, we get the answer is 3x power of 4 divided by 3x minus 1 plus 4x power of 3 ln 3x minus 1. Then we continue for the question B. The given function is y equals to 4x squared plus 1 over sine 2x. Since the function is a fraction, I will use the quotient rule. The quotient rule states that d over dx times u over v equals to v du over dx minus u dv over dx divided by v squared. Then we let u equals to 4x squared plus 1 and v equals to sine 2x. Then we differentiate the u, so we get du over dx equals to 8x. Next, differentiate the v equals to sine 2x using the chain rule. dv over dx equals to cos 2x times 2, so we get 2 cos 2x. Then we substitute into the quotient rule, so we get dy over dx equals to sine 2x times 8x minus 4x squared plus 1 times 2 cos 2x. Then we divide it with sine squared 2x. Therefore, dy over dx equals to 8x sine 2x minus 2 times 4x squared plus 1 cos 2x. Then we divide it with sine squared 2x.
Good morning everyone. Today I will explain how to find dy over dx using implicit differentiation. The given equation is 5ye to the power of 1 minus x plus 8 cos 2y equals to x cubed plus 7. Since y is mixed together with x, it is difficult to make y the subject of the equation. Therefore, we use implicit differentiation. First, we differentiate both sides of the equation with respect to x. For the first term, 5ye to the power of 1 minus x, we use the product rule because it is the product of two functions, which are 5y and e to the power of 1 minus x. Using the product rule, we differentiate 5y and get 5y over the x. Next, we differentiate e to the power 1 minus x using the chain rule. The derivative of 1 minus x is negative 1, so the derivative becomes negative e to the power of 1 minus x. Applying the product rule give negative 5ye minus 1. Applying the product rule give negative 5ye to the power of 1 negative x plus 5e to the power of 1 negative x dy over dx. Next, we differentiate the second term, which is 8 cos open bracket 2y and close bracket. We use the chain rule because there is a function inside another function. The derivative of cos 2y is negative sine 2y times 2 dy over dx. Multiplying by 8 give negative 16 sine 2y dy over dx. Now, we differentiate the right hand side. The derivative of x cubic is 3x squared, while the derivative of 7 is 0. So, after differentiation, the equation becomes negative 5y e to the power of 1 minus s plus 5e to the power of 1 minus x dy over dx minus 16 sine 2y dy over dx equal to 3x squared. Next, we collect all terms containing dy over dx on one side of the equation. This gives 5e to the power of 1 minus s dy over dx minus 16 sine 2y dy over dx equals to 3x squared plus 5ye to the power of 1 minus x. Then we factor out dy over dx. We get open bracket 5e to the power of 1 minus x minus 16 sine times 2y close bracket. Dy over dx equals to 3x squared plus 5ye to the power of 1 minus x. Finally, we divide both sides by 5e to the power of 1 minus x minus 16 sine times 2y. Therefore, the value of dy over dx will be equal to 3x squared plus 5ye to the power of 1 minus x over 5e to the power of 1 minus x minus 16 sine times 2y. In conclusion, this question requires both the product rule and chain rule because the equation contains products of functions and composite functions. After differentiating and rearranging the terms, we obtain the final expression for dy over dx. Thank you.
Moving on to the question 4. Now I'm going to explain about the linear approximation to estimate the value of 4 root 80.98 minus 80.98 over 2 square. Correct to two-dimensional place. First, write the equation 4 root 80.98 minus 80.98 over 2 square. Change the same number to x and put the equation into the fx form. Fx equal to 4 root x minus x over 2 square. And then we're going to differentiate the equation. And then we're going to get fx equal to x exponent 1 over 4 minus x over 2 square. And for the f prime, we're going to get 1 over 4 x exponent 3 over 4 minus 2x over 2 square multiply 1. For x, we already get the number from the equation, which is 80.98. And for the x node, we choose the number that closer to 80.98 and we root the number and we will get the whole number. So which is I get right now is 81. So we're going to use this formula is dx equal to x minus x node. So the equal 80.98 minus 81 and we're going to get minus 0.02. After that, we're going to use the same equation of the fx and f prime but change the x into the x node. We're going to get here f81 equal to 81 exponent 1 over 4 minus 81 over 2 square. We're going to get minus 1637.25. So for the f prime, f81 equal to 1 over 4 81 t exponent 3 over 4 minus 2 81 over 2 multiply 1 equal minus 74.25. And after we got the solution, we're going to use this formula, which is fx equal f node plus f prime node multiply dx. So put the solution and then minus 1635.77.
In summary, the technique of implicit differentiation is an incredibly powerful and versatile tool in calculus. It allows us to differentiate equations where y is defined implicitly in terms of x, which is crucial when implicit formulas are hard to come by. For example, consider the equation of a circle x squared plus y squared equals 25. Using implicit differentiation, we can find the slope of the tangent line at any point in the circle. Similarly, in physics, when studying related rates like how a shadow length changes as a person walks, implicit differentiation helps us relate the rates of change of different variables. By applying this method, we can solve real-world problems in physics, engineering, and beyond, expanding our ability